Hello, and welcome to another digital lecture for Salt Lake Community College. This lecture will continue to cover section 5.5 for Introduction to Statistics, the multiplication rule, and conditional probability. There are only a few definitions and formulas in this section that we would like to feel comfortable with. The first is the definition of a conditional probability. A conditional probability is the probability that an event occurs given another event has already occurred. One of the key words in this definition is the word given. When we read the word given, this will be an indication that we're looking at a conditional probability. There are also two different events that are part of our conditional probability. The first is the outcome of interest. This is the event for which we want to compute the probability of. It is also the event that is given in the first part of our conditional probability. The second event is referred to as your condition. This is information we know to be true, the event that has already occurred. To calculate the conditional probability of the outcome of interest A given condition B is computed as follows. Now, the notation we use for a conditional probability is written as the probability of A given B. Here, the vertical line is interpreted as the word given. So this is read as the probability of event A given event B has already occurred. And this probability can be computed using the fraction, where we look at the probability of A and B occurring at the same time, divided by the probability of B. I'll look at an example of this with you in just a moment. Another way that we can use this conditional probability is to derive a general multiplication rule. If A and B represent two outcomes or events, then we can solve for the probability of A and B in our previous formula by multiplying by the probability of B to get it on the other side of our equation. This will give us that the probability of A and B is equal to the probability of B times the probability of A given B, where we think of event A as the outcome and event B as the condition. We will use the general multiplication rule when our outcomes are not independent. When our outcomes or events are not independent. We will also look at some examples to follow. Let's look at our first example. In this table, we are summarized the results of a Pew Research poll where U.S. adults were asked whether they approve or disapprove of the President and the members of Congress. It is also broken down by whether they are asked about Democrat presidents, Democrats in Congress, or Republicans in Congress. In Part A, we are asked to find the probability that a randomly selected U.S. adult American approves, given they are being asked about Democrats in Congress. Notice the word given that indicates we're looking at a conditional probability. Now, this question can be phrased as the probability that they approve given they're being asked about Democrats. Using the right side of our definition, this can be calculated as the probability that they approve and are being asked about Democrats divided by the probability that they're being asked about Democrats. Now, in our numerator, the probability that they approve and are being asked about Democrats is going to be the 736 divided by our table total. The probability that they're being asked about Democrats is going to be the total number that we're asked about Democrats divided by our table total. Recall, when we're looking at a complex fraction, a fraction divided by another fraction, we can rewrite this as a multiplication by the reciprocal of our denominator. Notice in doing so that the 4,223 will cancel. And so that this is equivalent to just 736 divided by 1382, which is approximately 0.533. Now, an alternate approach we could have used is to think of the condition being asked about Democrats as restricting ourselves to just this one column. Notice that the probability that the U.S. adult American approves, given that they are Democrats, could be calculated by just looking at those that were both approving and being asked about Democrats divided by that column total. This alternate approach is generally preferred. Again, when we read this condition, we think of the condition as restricting ourselves to just that group of people. Let's look at another example, or another part of this question. In Part B, we are asked, what is the probability that a randomly selected U.S. adult is being asked about Democrats in Congress, given that they approve? Again, notice the word given that tells us we're looking at a conditional probability. We can write this as the probability that they're being asked about Democrats, given that they approve of the job they are doing. Again, notice the vertical line being interpreted as the word given. Now, let's use the alternative approach to calculate this probability. Here, the condition is that they approve of the job they are doing. So if we restrict ourselves to just this group of people, and then ask ourselves, of that group, how many are being asked about Democrats? and that would be the 736 out of that group's total, or 736 divided by 2,119, which is approximately 0.347. In the last part of this question, we are being asked, are being asked about Democrats in Congress and approving of the job they are doing independent events. Recall, two events are independent if knowing the outcome of one event provides no useful information about the outcome of the other. We can test this by asking if the probability of being a Democrat, given that they approve, is equal to the probability of being asked about Democrats. If these are equal, then knowing that the adult approves will provide no useful information about being asked about Democrats in Congress. Now, in part B, we already calculated the probability of being asked about Democrats given they approve as 0.347. On the right-hand side, being asked about Democrats in Congress. This is going to be the total number of Democrats in Congress divided by that table's total, which is going to be the 1382 divided by the 4223, which is about 0.327. Notice that these probabilities are not equal. Because these probabilities are not equal, we can say that being asked about Democrats in Congress and approving of the job they are doing are not independent events. This about covers all the examples I want to cover in this video. If you have further questions, be sure to review the example videos that follow or ask your instructor.